I'm Brant Burnett from CenterEdge Software, and this presentation will be about lightning fast continuous delivery in an ultra safe way when you're using Couchbase. First, let me tell you a little bit about us. CenterEdge Software was founded in 2004, and we provide software solutions for the entertainment industry. So things like trampoline parks, water parks, skating centers, amusement parks. We do things like their ticketing solutions, their group bookings, birthday party bookings, online sales, and generally try to manage as much of their business through one software suite as we can. And over the last decade, we've been gradually transitioning more and more of our operations from on-premise servers into cloud-based applications, primarily in AWS, and primarily using Couchbase as our data store. I am the systems architect at CenterEdge Software. I've been using Couchbase Server at CenterEdge since 2012 when we started on version 1.8 of Couchbase Server. And I am also an open source contributor to Couchbase. I do some work around the .NET SDKs primarily, as well as some helper utilities, some of which you'll learn about today. And I'm also a Couchbase community expert. So this presentation is about continuous delivery. So what does continuous delivery do for us? I mean, when you look at some of the large companies out there, sometimes they'll talk about how many thousands of deploys they do a day. And frankly, when we first started talking about it, it scared me a little bit. But I quickly came to realize that the benefits of it, if you do it right, outweigh the risks involved. So the first thing it gets you is the ability to deliver your software to your customer much more quickly. If you're on a, let's say, 2 or 3 month release cycle, that means that if a customer comes to you today and requests a new feature and you think it is super valuable and that it would be absolutely awesome for your business, then you're looking at bare minimum 3 months to get that out the door and to the customer. Even if it's a relatively easy thing to develop, even if you can give it to your team and get it done in 2 days, you're waiting until your next release cycle to get it out. And so this isn't a terribly agile way of doing things. And an important part of agile development is the idea of continuous feedback from your customers. Develop it, get feedback, figure out what to do next. Don't assume that you know best what they need up front. And so continuous delivery really plays an important part in providing that kind of service. It also reduces developer friction. When you're working on a 3-month development cycle, you have to constantly kind of keep track of what's in production versus what you're doing and what sort of data conversions are going to need to happen when the deployment happens 2 months from now. So you got to do lots of documentation about what your deployment strategy is going to be to keep track of everything for all those months. And this kind of plays in with the idea of trunk-based development, which is the idea that your main branch in Git or whatever source control system you use is, the source of truth for what is in production. If it's been merged into main, it's what runs in production. And then as you continually work to make improvements to the software, you're continuously merging that into that main branch and deploying it to production. This eliminates merge conflicts for the most part. You have a lot less problems with stuff you're doing having conflicts with stuff other people did because you're always just doing very small units of work against that main branch. And you're not, doing your work based off something that was a month old. But also it's much simpler for the developer. They can conceptualize that idea of that main branch being what's in production much more easily, so that you don't have those confusion factors around what's in production and what's not, and what conversion processes still need to be run in production during the deploy. And if you're doing a microservice architecture, in my opinion, doing microservices without continuous delivery is a headache I would not want to take on, because so often you have inter-service dependencies. I need to make a change to service A, and I have to get that deployed before I can make and deploy the change to service B, before I can make a change to service C. And trying to keep track of all that to do a big deploy of all your services at once in 3 months versus just do it, deploy it. Just make sure you're always, have some backward compatibility in each of your deploys, and you're good to go with your inner service dependency so you can really get those dev tasks moving. But there are some challenges that come with continuous delivery. The first is schema deployment. Couchbase is a great database for this sort of approach because it's a schemaless architecture, or more precisely, the schema is not enforced by the database. There's still a concept of some schema to your documents, or else it would just be random gibberish. But you don't have data definition language updates you have to perform to define that schema to Couchbase Server. But that doesn't mean that there's no schema or DDL type stuff in Couchbase Server. You do have things like indexes, which do need to be deployed as part of your deployment process. And then the next challenge is automated testing. If you're going to do continuous delivery, you must do automated testing, or else you will have lots of outages. So having a good, robust automated testing infrastructure is important. And these days, it's not terribly hard to do, especially if you're doing an API-centric architecture, because it's logically much easier to test your APIs to make sure they're behaving the way you want, as opposed to the logical difficulties in testing an HTML-based UI, which is doable but much more difficult. And also, you want to do smoke testing, which is less robust than your full automated test suites, but which is going to kind of help you catch the little odd things that are happening as it goes out in production. But kind of a key point here, though, is that you want to do your testing before the merge. So it really needs to be part of your full CI process on your pull requests. You need to be running these automated test suites. But these test suites really need to be more than just unit tests. So how do you do that with Couchbase? And so we'll go over some of that. Monitoring is, of course, very important. If you're going to continuously deploy, you also need to have proactive monitoring in place. So if you deploy something and it has a problem, you know about it. So things like monitoring your red metrics, which is request errors and duration. So you see if, oh wait, my error rate just spiked, or my duration of my request just spiked because I just deployed an inefficient query. Or any of these other things that can happen. You want to have proactive monitors in place for them. You need a system to do rollbacks. So when those monitors alert, a developer will look at it and go, oh, okay, that's bad, and hit a button and very quickly get you back to your previous state. And then finally, feature flags, sometimes called feature gates. There's various other names for them, which allow you to roll out your software in a more piecemeal manner, to separate the concept of deploy from the concept of release, so that you are deploying continuously, but you're not releasing new features continuously, so that I can develop a new feature that takes me a month to develop, but I'm deploying the pieces of it by merging into that main trunk branch continuously through that month. I've just got it hidden and only turned on where only QA can see it, or maybe some beta sites can see it. So the first thing I kind of want to go over is how do you manage your nickel indexes without pulling all your hair out when you're trying to do this continuous delivery approach. What do I do with my indexes? To which end, let's look at this index, for example. This is a relatively simple index. Doesn't have a lot to it. It's got a name. It's got the bucket you're indexing. It's got two fields in the key. And then it's got a predicate to filter the documents in the index, which is going to typically be on most indexes that you'll make in Couchbase, in my experience. But then we also have a defer build flag. So the point is there's a lot of pieces here, and this is a simple index. It could have a lot more keys, including array keys. It could include partitioning, if you're doing a partitioned index across multiple index nodes, replica control, as well as even assigning it to specific nodes because you're trying to manage your memory utilization. You want specific nodes to have, you know, large indexes separate from your small indexes just to make sure you don't have any one index node that's overloaded and doing a lot of disk swapping. So managing that in a production continuously delivered environment becomes tricky at best. To which end we created Couchbase Index Manager. So Couchbase Index Manager helps you solve a lot of these problems. And so the different things that it does is, first of all, it's going to track your desired state based on files that you're committing into Git, right along with your application or in a separate repository, however you decide to organize it. And because it's in Git, now it's subject to peer review. So you can go through your pull request process on your index changes, or even go so far as running automated tests against your index changes if you want to. And then it allows for zero downtime deployments as best as it reasonably can. There are some changes that you might tell it to make that are going to cause some index to become unavailable to power queries for some period of time. But it does its absolute best to make sure that none of the changes it makes are going to cause downtime. It also handles deferring builds. So if you're trying to build 10 new indexes at once, it's far more efficient to create 10 indexes and then do one build of all 10 than it is to create and build them one at a time, because it only has to stream the documents to the index nodes from the data nodes once instead of 10 times. So that's built into Couchbase Index Manager. And there's also built-in support for handling multiple environments that might be different, as well as manual assignment of nodes. So the first thing to show you is the declarative syntax. So it's YAML-based declarative syntax, and it's the names of the fields are very much based on some of the REST APIs put out by Couchbase, and so it's named to be similar. This is, again, a very simple example. It's the example you saw just a second ago, but here you give it an index name, a list of index keys, and this can take complex functions, including array indexes and other things like that, as well as a predicate for filtering the documents that the index applies to. But you can do partitions on this, node assignments, replica count control, and all those different things right in this YAML file. And if you put multiple indexes in one file, you just do the 3 dashes to separate them like in a normal YAML syntax, and now you've got multiple indexes defined in one file. Or you can do multiple files with separate indexes, however you want to organize your repository. The really cool thing about this declarative syntax is this is not saying create an index called customers with those keys and that condition. It's saying make sure that an index that matches all of this exists in the cluster. So it actually goes out to Couchbase, actively pulls down the current state of all the indexes, and does a comparison and makes intelligent decisions about what changes need to be made and don't need to be made to bring the cluster in sync with the declarations that you have. And so this is what the mutation plan that it outputs would look like. Now, if you're running an automated way, you would auto-approve and not have the prompt for the sync at the bottom. But this kind of shows you that these are the things it needs to create to bring it in sync. If there were mutations, you'd see mutations. If there were drops of indexes that aren't required anymore, you're going to see drops in this list. And this gives you the opportunity, if you're processing manually, to review and make sure that you're going to get the desired changes and that nothing untoward is going to happen. So how does Couchbase Index Manager do the work to try to make sure that these deployments are safe? Because that's really key, is you don't want simply running a command line script utility as part of your deployment process to take your system down. So the first thing is, while it might need to do a drop and then a recreate sometimes, like if you change the keys on a particular index, if you say add a third key, there's no way to change that without dropping and recreating the index. But what it will do is run any other creates for other indexes and runs through all the creates for all the indexes it needs to create first before it runs any drops. So if you're, for example, you make a new index with a new name, that has the third column, and then drop the old index with the old name, that it'll do that create first, and that new index can start covering your queries before it goes in and performs the drop. Second, wherever possible, it will use an alter index statement. And this varies depending on your version of Couchbase Server. If you're on 6.5 or later, you get the most options for alter index. So the alter index command can do things like change the number of replicas or change the node assignments to move particular replicas from one node to another node. And so where the version of Couchbase Server you have supports those commands, it will use those instead of a drop and recreate. Finally, it has a system that I call manual replicas. So the automated replica management is pretty nice in Couchbase Server. You just say, I want this index and I want 3 replicas, and it will go out and put it on 3 nodes. And you can even tell it which nodes to put those 3 replicas on. But the big downside there is what happens when I do want to change a particular key. What happens when I want to add that third key to one and I don't want to go to a new index name for whatever reason. Or maybe I want to change the number of replicas and I'm on an old version of Couchbase Server where I didn't have the alter index statement. If you choose to turn on manual replica controls, instead of Couchbase managing the replicas, the Couchbase Index Manager will do so instead, creating multiple indexes with names like underscore replica 1 and underscore replica 2 on the end of it. And when that happens, it's able to phase the update so that it will drop one replica, recreate it with the new index keys, then drop the next replica, recreate it with the new index keys. So you actually get a rolling update of the change to the index without any downtime. Of course, it does all the build defer we talked about. And also, it will never do a just permanent drop of an index just because you delete it from the file. If you delete it from the file, it just stops managing that index. It's going to leave it out there. If you want to drop an index permanently, you actually need to leave it in the file. You clear out most of the fields and you put a life cycle drop true statement on there saying, I want you to drop this. So this helps, 1, prevent accidental index drops, but 2, it allows you to run this in the same cluster for multiple microservices that have their own definitions of their own indexes for each microservice without them interfering with each other, because they'll only manage their indexes when they run. It also has the concept of override files. So an override file allows you to go in and override any of the settings on a particular index with new settings. For example, here in this example, you see on the screen the breweries by address index is overriding the number of replicas to 0. And then it also demonstrates that even though this doesn't really accomplish much in this example, you can actually put JavaScript functions in to do more advanced things and apply intelligent logic to what it's doing in the override instead of just having it hard-coded in the file. The purpose of this is to allow you to define override files for different environments. For example, your dev QA environment is probably a smaller, less expensive environment than your production environment. You probably don't want to run 3 replicas of your index in your dev QA environment because you don't have enough nodes to support 3 replicas of your index. So you might want to run with no replicas in dev QA, but you do need your replicas in your production environment. Also, if you're trying to assign to specific nodes, then the names of those nodes might be different per environment, and so you might want to have these override files use different node names in each environment. But to further support that, it also has node maps. So node maps allow you to basically create aliases. So this map here is saying anytime you see a node name of node 1 on an index, it really means node1.couchbase.production.local. This makes it even easier to deal with varying node sets in different environments because I can define the same node assignments on the index definition and just change the map on a per environment basis. So here's the information on Couchbase Index Manager. It's available on NPM, so you can do an npm install -g to install it locally and run it. It's also available on Docker Hub, so it makes it easy to run inside Kubernetes to apply indexes inside your Kubernetes environment. And of course, you can go pull the source code from GitHub. Pull requests are welcome. And I will say that not only is this in use by CenterEdge, I have had phone calls with other companies whose names everyone in this room would probably recognize that we're looking at using it, and I believe are currently using it today. So if you have any issues with it, please file an issue, open a bug report. I will say it doesn't currently do full text search indexes, and that is something I'd probably like to add at some point. But it's not something we're currently using much of at CenterEdge, so I haven't had a whole lot of calls to spend time on it personally. But yeah, so that's Couchbase Index Manager. So this is one of the pieces of how we do continuous delivery at CenterEdge. The next piece of how we do it involves how we run Couchbase in Docker containers. And I'm not talking about how we run it in production in Docker containers. We do that with the Kubernetes, a Couchbase autonomous operator. In fact, we very recently upgraded to the 2.0 version of the operator. It's a great tool, makes managing your cluster very easy. But that's not really very particular to our continuous delivery pattern. The question is, when I'm doing local development or integrated tests, how do I run Couchbase? So to that end, we created Couchbase FakeIt. So Couchbase FakeIt is a Docker container image of Couchbase. Now you'll say, okay, well that already exists. Well, it does. But this is built upon the official Couchbase images. So we're pulling their official images from Docker Hub and using that as the starting point for Couchbase FakeIt images. But what this does differently is instead of just launching Couchbase and sitting there idle waiting for configuration via the UI or the command line, it has built in all the scripts that it needs to do to fully configure Couchbase when it starts. So it's designed for spin it up, get a running copy of Couchbase that has buckets in it, has your configured memory settings, creates your nickel indexes, creates your full text search indexes, creates your eventing functions. Only thing it doesn't do right now is analytics. And in doing so, that makes it very easy for whatever place you need to put this. And you just drop in some files. It's all based on just files in a folder that define all of these things. And the scripts are going in, looking at those files, scanning them, deciding what to do, and getting Couchbase initialized. And it's deployed for lots of different versions of Couchbase. Every time a new version of Couchbase comes out, we add it to our build scripts so that we're putting out new versions of Couchbase FakeIt for that particular version of Couchbase. So to start off with, where's it getting the fake data from? That's very important. So to which end it actually uses FakeIt, which is another project, but it's where the name came from. But FakeIt is an NPM system designed to generate fake data, which we use in Couchbase FakeIt to generate the fake data at startup. And we kind of do this because scale is important. If you're trying to do testing and you only have 3 or 4 customer records in your database, you're going to get potentially misleading results out of your tests. If you have, for example, if you have customers very poorly indexed, but there is an index, and you only have 4 in your database, a very poor index is still going to query across those 4 customers very effectively. If, on the other hand, you have 10,000 customers, you're going to see that your query is going to start breaking down even in your integrated tests. Now, that might not be as full scale as your production system that has 1 million customer records, but 10,000 or 100,000 will get you close enough to pick up most of your query problems and indexing problems in your testing system. Also, realistic data is valuable. You don't necessarily want to go in and create first name, F name, and last name, name 2, and things like that. Because when you do that, on your UIs, it's not going to really replicate things like longer names that are really going to happen in the real world. Everything's going to have the same width down the page, name 1, name 2, name 3, name 4. So having some degree of fake realistic data is important. And FakeIt supports using Faker and Chance JavaScript libraries to do things like, say, give me a first name, and it picks from a random list of actual first names. And of course, also, you could get scale and realistic data by just pulling back your production database, right? Yeah, it's usually not best practice, especially with customer data and other PII, credit card numbers, or who knows what else. You want to try to avoid leaking your real world data back to development and QA just for security reasons. Big thanks to Aaron and Tyler Benton, who are the creators of FakeIt that we reused for this. It's an awesome tool, and I encourage everybody to look at it. But here's an example of a very simple FakeIt model. So you can see, even in this simple example, some of the power that it gives you. This is saying I want somewhere between 6,000 and 10,000 customer objects. Pick a random value. It tells you how to build the key as customer dash and the ID. It says I'll just do an incrementing ID number starting 1 through 6,000 or however many you do. Type is a constant customer, but F name I want to get a first name from Faker. L name I want to get a last name from Faker. But it can do a lot more than this. It can go in and you can build another set of objects called orders. And you can have the orders objects refer to and pull IDs of customers from your already generated customers objects so that these IDs can all show up and have actual relational data between the documents. Because while Couchbase is not a relational database in that you tend to embed things inside documents, you're still going to end up with relationships between documents you want in your fake data. This can handle arrays and embedded sub-objects. You could put JavaScript functions to do more advanced building. I've done some pretty complicated stuff. And it could pull in CSV files if you have some static data. You want to be consistent and you don't want randomized. I'm not going to go into that further because that's a whole presentation unto itself. I just want you to understand what it can do. Now, the next thing you need is your nickel indexes when Couchbase starts up. And, well, this looks real familiar. I think we just looked at this a few minutes ago. We actually build a Couchbase index manager into Couchbase FakeIt. So you could put the exact same YAML file that you're using to deploy to production, except you probably want to have your override set for no replicas. But you put those exact same YAML files right in here, and it's going to create the nickel indexes for you. So you can actually have a single source of truth within your repository for what your indexes are. Alternatively, you can put nickel scripts in and have it just run through the list of nickel scripts to create the indexes if you wanted to use that mode, but I personally prefer this one. Now, full-text search indexes. Full-text search indexes are similar, except that they're much more complicated. So full-text search indexes are defined with a JSON object. So this is the JSON object that you would get if you go into the Couchbase UI and you hit, download the JSON off a particular full-text search index you defined. So the typical mode of operation is go into the Couchbase UI, click around, build this index, put all the pieces of it together, and then after you're done with that, download the JSON, drop it into the file on disk, and then you've got an index sitting there ready to go, and it's automatically created and built as part of your Couchbase startup. I forgot to mention, you can also create a JSON file to create a full-text alias. It's a pretty common deployment scenario for full-text search indexes to have an alias, for example, IDX_waiver search, that then points to IDX_waiver search -v9, so that you can deal with rolling builds of new indexes and point those aliases to the new index when it's ready. So you could do that inside your fake spin up as well to keep your names consistent by creating the alias. And then eventing functions. You can also create eventing functions. So there's two files involved in an eventing function. The first file is the actual JS file. So this is the actual JavaScript content of your event. And so this is an example one that we used to use that can go through and process these things and do these things. But you also need a configuration that tells things like which bucket names are alias to what aliases inside the JavaScript. And so for that, there's a JSON file that you put beside it. You make the JS and the JSON file just have the same name, just with the different extensions. And the JSON file has the configuration for the actual event that pairs up with that. Now that is the JSON that you can download from the REST API. So that's how you can get the format for that if you don't want to hand type all of that. What we're doing is actually taking that JSON object you see there, tweaking it just a little bit, and posting it up to the REST API as part of the spin up of Couchbase FakeIt. So the end result of all of those different pieces is, with the exception of analytics, you've now spun up a fully functional container with a full copy of Couchbase ready to go, just like it was sitting in a production environment so that you can test against it just in a container. Like I said, you can turn on analytics with Couchbase FakeIt. So if you use analytics, that's fine. You can turn the service on. It will bring it up. It will have it started and ready to go. It just doesn't do any of the DDL for it. So it's not going to define bucket connections or define indexes within analytics. Certainly stuff that could be added, however. So all of that really helps a lot with automated testing, but I just want to point out that while it's not directly applicable to developer experience, using a containerized Couchbase like this is very important for your developer experience, in my opinion. I like to call it, we use Visual Studio, so I call it the F5 developer experience. I want the developer to be able to pull down a repo, hit F5, and just run the application. So by using this containerized Couchbase FakeIt approach, even for how your developers do their development, not just for how the automated tests are run, you are avoiding installing Couchbase on the developer's machine. That's one less thing they have to download and install before they can get started. Also, if you're running a big enough system, you quite possibly have more than one Couchbase cluster running in more than one different version. I know we have two clusters running two completely different versions of Couchbase. They don't get upgraded at the same time. We have different projects that use the different clusters. You don't want to have your developer uninstalling and reinstalling different versions of Couchbase on their machine as they switch back and forth. You could just always run on the latest version of Couchbase, but then you run the risk of thinking something's going to work on your local machine that's not actually going to work. Because as new versions of Couchbase come out, their query interpreter gets better, their index selection gets better, the capabilities of the indexes improve. So they could easily write an index and query combination that you think is going to work, but doesn't work on an older version of Couchbase. Second, with all the fake data, when they pull up their development environment, they're ready to go. They don't need to go in and build up data records to have something to test against. It's all there. So the developer can go in, browse the customers, click on customers, edit customers, whatever actions they need to do to get done with whatever task they need is already ready to go for them when they hit F5. And then they can also quickly return to a valid ground state between tests. Sometimes when you're testing something, it's based upon a situation that in the course of testing is no longer the situation anymore. And you can't reproduce the problem again until you go back to your starting point and delete some records out of the database or whatever you need to do to get it back to the correct position. And so this makes it really easy for you to just tear down the Couchbase container, spin it back up again, and be back at that valid starting point. And then QA can use this to deliver that consistent starting point. So if QA finds a bug, they can give a set of steps to reproduce that are based on that starting point, and then give that to the developer in the bug report, and the developer can easily reproduce it from the exact same starting point from that Docker container spin up. So you eliminate a lot of the "it works on my machine" issues. Not all of them; they can still happen, but it takes care of a lot of them. And so I think this is really important, not specifically for continuous delivery, but for agile development. Anything you can do to reduce developer friction in between each task they're working on, how long it takes them to switch from I got done with this task, start on the next one, is going to overall increase everybody's productivity, their happiness, And it fits well with doing continuous delivery because you're tending to do smaller tasks and delivering them in smaller bite-sized chunks. So there's a lot more of that task switching happening. So here's the information on Couchbase FakeIt. It is available on Docker Hub, so you can just pull the image and use it. It's got tags for different versions of Couchbase that you want it to pull, so that you can match to whatever version of Couchbase you have in your infrastructure. We usually don't keep up with minor point releases. Like if I add a new feature to Couchbase FakeIt, I'm probably going to release it for 5.5.1 and 6.0.4, but not 6.0.3 and 5.5.0. But those images will stay out there for anybody who's using them, and will continue working. It's also on GitHub. Feel free. Again, love pull requests. Bash scripting, not my strongest suit. I'm really more of a PowerShell guy. I've been a Windows guy for a long time, so I'm sure if you look at all the bash scripts over in there, they probably look ugly to all you Linux people, but they do get the job done. And then finally, I recently made a GitHub action called Run Couchbase FakeIt that actually makes it very easy to launch Couchbase FakeIt within a GitHub workflow. So if that helps you with any integrated testing, please feel free to play with that. So then how do we add these automated tests to use this containerized Couchbase that we just made? So our containerized testing at CenterEdge is kind of based on a 3-container approach. So we're going to use a Docker Compose file to define the containers we want to spin up. One of them will be Couchbase FakeIt with a volume mount. And this volume mount has all the configuration files so that it configures it correctly. Another will be the actual application. In our case, it's usually .NET Core, but it could be anything. And then the third container is the actual test container. This is the container that actually has the tests that we're going to run. These we typically do Node.js TypeScript-based testing, but again, could be any language. I know there are a lot of people in the automated testing world who like Python, so it could certainly be Python instead. We ended up settling on TypeScript and in some cases JavaScript, just because that was what most of our developers were familiar with, and we were kind of training up QA analysts into QA engineers. So, it helped, with our skill sets and stuff like that, but it's really just to pick the right tool for the job scenario. So what does containerized testing in this way get you? First of all, it's going to get you consistent tests on local machines and build agents. That means if I run the test in Jenkins or GitHub Actions or wherever I run it, 99.9% of the time, I'm going to get exactly the same result as if I were to run it on my QA engineer's machine in their containers versus if I run it on a developer machine in the containers. It's all super duper consistent. We've occasionally run into weird quirks with Docker and Linux versions and kernels and stuff, but 99.9% of the time you're going to get the same results, unless it's a race condition. Race conditions will throw you off. A machine with more cores will hit race conditions differently than a slower machine. It's much faster than spinning up VMs to do the same thing. You could do the same 3-layer test I just showed you with 3 VMs. But spinning up VMs, just launching one takes a few minutes, and a container takes seconds. So you're able to get that testing much better. Also, doing something to do the same thing with VMs on your local machine versus in AWS is very different. Vagrant can help, but it's a lot more cumbersome, I think, than dealing with Docker containers. Because it's running much faster, now I can make this part of my pull request. You can't merge a pull request in our systems until these automated functional tests on that service pass. And one of the things we do is the QA engineer is actually putting in the tests on the same pull request. So the developer creates a pull request with all their changes, and then the tests against it, in our case, live in the same repo. And so the QA engineer comes in, takes that branch, adds any additional tests that they need to it, pushes those up a little pull request, all gets peer reviewed, and then all gets merged in one shot once everything's passing. And again, much like with the developer stuff, now I can easily reset to that ground state between runs. One of the things you don't want to do is have the data leak in between test runs. This makes it very easy to, in a matter of Couchbase FakeIt usually takes 20 to 30 seconds to launch, depending on how much configuration and stuff you've got in there. So it makes it pretty quick for you to reset to a ground state in between test runs when you need to. And then finally, you can include other dependencies. It's unlikely that your only dependency of your application is Couchbase. You're probably storing files in S3, or you've got a message bus like RabbitMQ or Kafka. You might be doing search with Elasticsearch. You might be talking to other microservices in your architecture, which of course you want to keep to a minimum, but sometimes you need to. And in any of those cases, to do functional testing on this one service, I need to be running mocks of those things. I don't want to go out and hit the production S3 bucket to store customer pictures when I'm testing a microservice for customers. I want it to hit a mock of S3. So you can add additional containers to the Docker Compose file for those cases. Local stack, for example, for mocking AWS services. You can actually add a RabbitMQ instance. You can actually add an Elasticsearch instance. And so just add those things to your Docker Compose file, maybe with a little bit of scripting, and you're good to go. There are a few additional considerations in this pattern. One is you want to make sure you're aware that the containers will start in parallel. That means it's going to launch Couchbase, your application, and the test suite container simultaneously. And clearly, your application is not going to work until Couchbase is not only started, but Couchbase FakeIt scripts are done running. And clearly, the tests are not going to work until your application is up and running. So you need to do a little bit of work to make sure that everything is up and ready in between tests. The other thing to watch out for is if you're using any kind of shared volumes, which you probably will. We'll go over that in a minute. Shared volumes persist between runs. They're not deleted. Unless you expressly tell Docker Compose to delete them by doing a Docker Compose down with the -v switch. And that will cause it to delete the volumes so that you don't have those volumes leaking between test runs. So this is a somewhat simplified example of a Docker Compose file. I would not call it simple, but this will do the job that we're talking about. So you see the first service at the top is Couchbase FakeIt. There you see the very first volume mount. That's where we're mounting into the startup folder in the container, a local folder, in this case the Couchbase folder, that has all of the configuration files we talked about for buckets and indexes and fake models and events and all that stuff. But we also mount up a couple of shared volumes as well. And then we expose port 8091 so that I can get into the management console if I need to do some research. Then the next thing is, okay, here's the actual application I want to test. And here you override some of the configuration in the application. Here, this is using .NET Core syntax for overrides into the .NET Core configuration system, but it could be whatever. But in particular, I'm passing in a ready file. So the application startup code has got a check, and if that environment variable Couchbase ready file is set, then it's going to monitor for that file to exist. That file node status initialized is on that shared volume between the test container and Couchbase. And so Couchbase FakeIt writes and creates that initialized file whenever it's done. So by monitoring for the existence of that file is how the application knows, okay, I can finish starting up now because Couchbase is up and running. And then also connection string, all that fun jazz. And then finally, you've got the actual test container. Now the test container is my actual, in this case, Node.js test suite. But again, you'll see that I'm passing in some environment variables. The first is, what's the base URL of the application I'm testing? So how does the test suite know to talk to the application I'm testing? And then the other is a ready URL. So that's just the URL that it will poll. And so we'll keep calling that URL on the application under test, watching for that to be return a 200, say, hey, I'm ready. at which point it knows it can actually start its test run. And so that effectively, transitively, is waiting for Couchbase to be ready as well, because that ready won't return until after the wait on that node status initialized file. But now at this point, this Docker Compose file is ready to run. And so this is the command line you would use to actually run the tests. You would do a Docker Compose up, and then the key here is exit code from tests. That is picking the service name. So if we come back here and look at the service name was tests in the Docker Compose file, we use exit code from tests. What that tells Docker Compose to do is, one, it's going to shut down all of the containers as soon as that test container completes. So it's not going to sit there and leave Couchbase up and running on your build agent. It's going to clean it up, tear it down. Or at least it's going to stop it, I should say. You would typically follow this with a Docker Compose down command to actually tear down everything. But secondly, it tells you, hey, if that test container exits with an exit code of 5, I want Docker Compose to exit with an exit code of 5. That's what's going to get the fact that it failed back out of the container and out into your scripting layer and therefore to your build agent, and it will see, hey, this finished with a bad exit code, this must have failed, and which will then mark your actual run as failed in your Jenkins or whatever GitHub Actions, Travis CI, whatever you're using. They're almost all are looking for exit codes coming off the commands. And so I've created a fully functional example of this. It's available at this GitHub URL you see here. It is a fully runnable. It's built on VS Code instead of Visual Studio. We do all our stuff in Visual Studio, but I know that that could be problematic for Mac users, and also Visual Studio Professional is paid. VS Code's free. So this way, any of you should be able to just install VS Code and an extension. The instructions are in the README, and you can go through and see how it works. It's got README files. It's got summary information. Please let me know if anybody has any questions on this. I can continue to update this example and make it better if there's any confusion on any of the points. Just file issues on the GitHub repo. I'm happy to look at it. So let's just take a few minutes to talk about some of the other tooling at CenterEdge Software that we use to help drive our continuous delivery process and how it kind of fits in with all the other stuff that I've gone over so far. So the first thing is Datadog. Datadog is what we use for our monitoring and metrics. So it wires up out of the box with Couchbase so that it can pull in all the Couchbase metrics. And so that you can have alerts set on cache miss ratios and other things like that to help you know if you have a deployment problem. In addition, we're, of course, pumping all sorts of other metrics directly out of our applications, like our red metrics and things like that. All go to Datadog, as they can all be correlated together, and we create lots of dashboards, alerts, that sort of thing. If you're going to do continuous delivery, you need some sort of metricing solution. Now, there's a lot of other solutions out there. I'm not saying Datadog is necessarily the right solution for you, but make sure you do something. Don't just count on going into the Couchbase dashboard in the management UI and looking at metrics every now and then and thinking that's all you need to do, not in a production environment. I do know that the professional services team at Couchbase has put together some fancy stuff with Prometheus and Grafana, I believe, that you can get from them that would help you as an alternative that's free. So I would certainly consider looking into that. The cool thing about Datadog is we're doing primarily deploying Couchbase into Kubernetes using the autonomous operator. So this is an example of the data that we put onto the pods as annotations. So this configuration goes into the configuration on the autonomous operator. And then from there, when it creates the individual Couchbase pods, it will also copy these annotations onto the Couchbase pods. This is picked up by the Datadog agent, which is running as a daemon set inside Kubernetes on every node. And it will see this and know, oh, this pod is Couchbase. It will connect in and pull all those metrics and forward them onto Datadog for you. All you got to do is include this info if you've got the Datadog daemon set. Only tricky part here is the username and password. Those are getting pulled from environment variables, so you also need to make sure that those are on the environment variables for your pod, typically as mounting secrets. The next piece of our puzzle is Spinnaker. So Spinnaker does all of our deployment management. So basically it goes out and does the deployments whenever things have been merged into the main branch. So it can handle a lot of the more complicated things for us. So we can define pipelines that go out and do things like run smoke test jobs, or that deploy to pre-production, and then after that's good, deploy to production. Or that, it may be in some high-risk services have a wait for a human to confirm that, yes, go forward with the deploy. It has support for doing canary analysis, though we don't really have that set up fully right now, but it can definitely do blue-green deployments with rollbacks and do all that stuff for you. And it integrates with multiple cloud providers. We have it deploying AWS instances using AMI images. We have it also deploying Docker containers into Kubernetes. It can do Google Cloud, Azure, any of those things, all from one platform. So it can even do, if you have a cross-cloud infrastructure, it can manage that for you. Spinnaker was actually originally developed by Netflix and was eventually open sourced by them. Google's very involved in the development of Spinnaker now. So it's really a great tool. It's got a bit of a learning curve. A little bit of setup work to get it running. It's not like a one-click deploy, but it runs in your Kubernetes cluster is usually the easiest way to deploy it. But it's really sweet once you get it up and working. So I wanted to kind of go over what our flow is in regards to Spinnaker, how that flows through our system, and kind of give you the full picture of what our continuous delivery pipeline looks like. So the first step is user creates a pull request. That pull request is going to trigger our unit tests and build, and also run the isolated integration tests, which is the name on this diagram for that multiple container spin up with Couchbase FakeIt, run that test suite. So Jenkins is going to do all of that for us as part of its test run, and we'll report that back on the pull request. Until it's successful, we can't merge. Once developers have approved it, that's successful, we're ready, we merge it. Merging it is going to then trigger the primary build in Jenkins. So this is going to actually make the official build. And it will rerun all those tests again on the official build, just to make sure. And then after that, it's then going to trigger Spinnaker. Now, we used to use Docker triggers, and we still do in some places. A Docker trigger is where Spinnaker is just waiting for a new Docker tag to get deployed up to the Docker registry, and when it sees it, it deploys it. We've switched a lot of our newer stuff to using an actual direct Jenkins integration with Spinnaker, so that seeing the Jenkins build succeed successfully then triggers Spinnaker to run the build, and it uses an artifact file that has the Docker tag information to get that Docker tag information over to Spinnaker. That pipeline is then going to do a few things. First of all, it can go out and run jobs either back in Jenkins, or it can run jobs in Kubernetes. So it can go out and do things like run your index deployment script to synchronize your indexes, things like that. And then it can go out and deploy to pre-production pods. So we're going to deploy the new version of the service to pre-production pods. This is running in the exact same Kubernetes cluster. They are wired to the production database. They are wired to all the other services or production services. The only difference between the pre-production and the production pods is that the pre-production pods are running behind a different load balancer, so they're not receiving any traffic coming to them. Other than we then trigger a smoke test run in Jenkins. The smoke test run hits the alternate load balancer with tests, and tests those in so that it's hitting the pre-production pods. And so this is making sure that, okay, this new version can connect to Couchbase. It does do its basically functional things. Nothing is crazy wrong with it. It's mapped, the configuration is mapped correctly because it's pulling the same configuration from Kubernetes that the production pods are. And then after that is complete and successful, then Spinnaker will spin those pods down so you're not wasting resources. And then it will actually do the blue-green deployment to production. So that spins up a new set of pods and changes the load balancer to point to the new pods instead of the old pods. And then the old pods are left there so we can switch back if we need to. And then actually, it doesn't show it on this diagram, but then it calls back to Jenkins and runs the smoke tests again, this time directly against the production pods because you can't be too careful. So this is kind of what our overall flow of how we get this stuff out from pull request all the way out to production, running these Couchbase integration tests, running the indexes out to Couchbase, and doing all of that fun stuff. And kind of the final tool in our toolkit is Launch Darkly. So Launch Darkly is how we manage our feature flags. So it allows us to go in and configure a particular flag to be on for a client, a subset of clients, a particular user, whatever combination of things we need to. We can do percentage rollouts. So I could say 10% of users and then come back tomorrow and make it 20% and monitor to see if there's problems with these new features. And it uses like live socket connections that do push down events. Kind of a Signal R type thing, but I don't think they use Signal R. So that those flags are getting out to the microservices that need them, or into the browsers that need them if it's a browser level flag in less than 200 milliseconds from when you change it. Combined with doing reactive stuff on your UI is really cool. So I just flip a flag here and then I just see the UIs all change almost instantly. It's really neat. A system like this is really important for helping you control blast radius when you're doing these things and to do that separation between deploy and release. What I will say is that Launch Darkly is not exactly cheap. We chose it because of the robustness of it and how robust its feature set was and compared to what we could develop in-house. For a small project, I would seriously consider doing feature flags in Couchbase. I think Couchbase would be, given its memory-first architecture, would actually be a great store for basic feature flag information. And every single page request, you could just check the feature flags out of Couchbase. As long as you don't need as robust of a feature set as we have from Launch Darkly, I think that would be a great, inexpensive solution for you starting out. And you could move to something like Launch Darkly later if the need arose, or roll your own system if that fits your needs. But that is the presentation. That's how we do our continuous delivery with Couchbase. So thank you very much for your time. Hopefully you learned something. I can be reached at btburnett3 on Twitter. I've also got a blog that I post to every now and then at btburnett.com. And I'm also on the Couchbase forums and on Getter IM in the Couchbase discussion group. So any kind of questions you have, anything like that, please let me know. Thank you very much.